Hello, welcome to the Quiz 6 answer time with Mr. Reinheimer. We will go on a glorious journey through 5 questions, and when we are complete, you will feel prepared, and you will do well on the upcoming test, especially if you pay attention. Shall we get started? Okay. I'm looking forward to our time together. We're going to find the vertical and horizontal asymptotes, the x and y intercepts, and then graph the function. So, let's go ahead and find out our vertical asymptotes to start off. Okay, so that's where we have division by 0. And so we're going to set our denominator equal to 0, and then we're going to figure out the x values that will cause our denominator to be 0. So we're going to factor, and we have a 5 and a 2 minus 5 plus 2. That means we have vertical asymptotes at a minus 2 and a plus 5. Okay, so the horizontal asymptote is 0 because in the numerator we have a power 1 and in the denominator we have a power 2. The denominator degree is larger, so that means our horizontal asymptote is equal to a 0. The x-intercepts, there's actually only one. We find that by setting our y value equal to 0. And what happens if we multiply both sides by the denominator, we just end up with the numerator equals 0. So we end up with x equals a negative 1 when y is 0. So minus 1, 0. And finally, the y-intercept occurs when x is equal to 0. And if we plug in x equals 0, then we end up with let's see, a 1 over a negative 10. So negative 1/10. Okay, so I have everything plotted here. I have the vertical asymptotes. I have the horizontal at 0. I have the x and y intercepts. And so we'll start there. We know that we have to go through these 2 points. And as we get closer to this asymptote, we're just going to travel upward. And we're going to go over to this asymptote and travel downward. Now remember, we see the split behavior with the asymptotes when we just have a multiplicity of 1 in the denominator. So this guy's going to go down to negative infinity, since this guy's going up to positive infinity. And this guy is going to go from positive infinity. And because this one's going to negative infinity. And we see that our graph is going to continue out towards 0 on both sides. Okay, remember that you can always plug in points to be absolutely certain. Let's go ahead and jump to the next problem. Okay, so this problem 2 here, we have vertical asymptotes at 4 and negative 2 because that's where we have division by 0. The horizontal asymptote is equal to 1 because the degrees in the numerator and denominator are the same, and so we divide the leading coefficients and we get a 1 over a 1, which is a 1. So we have a horizontal asymptote at 1. The x-intercepts occur at the zeros of the numerator, and then the y-intercept is when x is equal to 0, we have 1/4. So I have everything plotted for us. And so first thing I'm going to do is I'm going to go through my intercepts, and I'm going to approach my asymptotes, and we're going to see that split behavior, and we're going to go off to 1 as x goes to negative infinity, y goes to 1. As x goes to positive infinity, y goes to 1. Alright, so this last problem here is one which has no horizontal asymptote because the numerator degree is larger than the denominator degree. So we have a slant asymptote. It's a linear slant because I know it right off the bat because x power 2 over x power 1 is going to give me an x to the first, and that is linear. And so that's really the big difference on this one. I'm going to go ahead and set things up for you. Okay, so I have everything done for us so far. We just need to complete the graph. Let's go through this here. Our slant asymptote, which is just a type of ending behavior, as is a horizontal asymptote, a type of ending behavior. That is equal to x plus 2. This is the quotient. We look at the quotient to see our overall end behavior, because as x gets larger and larger and larger, the more insignificant that fraction becomes. So we just look at the slant, the quotient, which is the slant. So let's see here. We have a vertical at 3. We have x-intercepts and a y-intercept. Let's go ahead and first start off by going through our intercepts. Well, we're going to approach our asymptote, get closer and closer, and go down to negative infinity there. Y negative infinity, yes. We go x equals, as x goes to negative infinity, we're going to approach the quotient y equals x plus 2. And so we got that split behavior, so we're going to come from positive infinity, and we're going to swoop around, and as x gets larger and larger and larger, we're going to approach that line, x plus 2. All right. So let's move on. But before we move on, remember, you guys, that you can always plug in points to be absolutely certain of yourself. Okay. So what we want to do is on this problem here, we want to use this given 0 to find all the zeros and write a linear factorization. So the first thing that we know is that because this complex number is a 0, that the conjugate is also a 0. And let's go ahead and start synthetically dividing to find the other zeros. We're going to break this down with synthetic division. Okay, so you can see that I've synthetically divided with that complex number, and you have all my work surrounding. I have stopped right here to show you guys that I know I'm on the right track here, because when we multiply 1 plus 2i times 2 minus 4i, we have two conjugates of each other. And what I've done here is I've factored out a 2 to see that we have two complex conjugates. And remember that when you multiply two complex conjugates, you end up getting a real number. And so I know that I'm on the right track here because I need a 10 here. And like I said, when you multiply two complex conjugates, you get a real number. And to just show you that work right now, we have 1 times 1 is 1. And then a minus 2i, and then a plus 2i, and then a negative, a positive times a negative. We get a negative 4i squared, which is actually a plus 4, and minus 2i, plus 2i crosses off. We have 5 times 2, which is 10, so we do get a 10 there. And I felt pretty confident that I would end up with the right thing. Because of the two conjugates. Okay, so I've also synthetically divided with the complex conjugate, and we have our result there. It's quite a bit easier this time around. So I'll go ahead and set up the linear factorization so far, and we can see what our progress is. Okay, so here's the linear factorization, what we have so far. And I need to find my last two zeros, and thankfully I have a trinomial here that can be factored. Otherwise I would have to use the quadratic formula, or I would have to complete the square, which would just take more time. So we have 2x times x is 2x squared, And then the last spot we have a 2, so that's a 2 times a 1. We need a 1 and a 2 here. The outer 2, 4x, the inner 2 is 1x. We need a minus 2 to get a minus 4x, and a plus 1 to get a plus 1x. Minus 4x plus 1x is a minus 3x. So this here is our complete linear factorization. The complete linear factorization is shown right here. And the zeros consist of 1 minus 2i, 1 plus 2i, a negative 1/2, and a positive 2. Alright, let's go to the last one. Alright, so we need to write the polynomial in standard form of minimum degree. I wrote in standard form twice. What do you know? Okay, with real coefficients whose zeros include those listed. So we have a 0 at negative 2, which means x plus 2 is a factor. And we have a 0 at 1, which means x minus 1 is a factor. We have a complex number, 3 plus I. So x minus the quantity 3 plus I is a factor. And remember that if we have a complex number as a 0, and we have a polynomial with real coefficients, then that means that the conjugate of that complex number is also a 0. So that means that 3 minus I is also a 0. And so we have another factor that says x minus the quantity 3 minus I. So we have our setup, and what we need to do from this point here is put the polynomial in standard form. So we need to multiply everything together. I would like to note that we're not told that there is any a value, and so we have to assume that our a value is just equal to a 1. Remember, the a is what stretches or shrinks our function. So I'm going to go ahead and start off by multiplying the two complex factors. So we have x times x, and then x times the quantity minus in front of the quantity 3 minus I. So we have a minus x times 3 minus I, and then we have the quantity minus 3 plus I times x minus 3 minus I. Okay, so we're going to have a minus x times 3 plus I, and then minus minus is plus, and I'm going to pause it right here because I'm running out of time. I'll show you the work in a second. Okay, so here we have it simplified to x squared minus 6x plus 10, because plus ix minus ix will cancel, and we have a minus 3x minus 6x gives us minus 3x minus 3x gives us a minus 6x, and we have a 9 minus I squared. I squared is a negative 1, so that's like saying 9 plus 1, so we got a 10 there. We have to multiply this trinomial times another trinomial, which we get from multiplying these two binomials, which will result in x squared plus 1 minus 2. So let's multiply these two trinomials together. Okay, so you can see my work here, which results in the polynomial equation, which is equal to a y. What I did is I color coordinated for you so that you could see that this red x squared multiplies to all these guys on the right, the blue multiplies to guys on the right, and the purple multiplies to guys on the right, and we add straight down to get our resulting polynomial. Thank you for joining me in the Quiz 6 Reinheimer Answer Hour. It's been real swell. I hope you enjoy it. I'll see you next time.